You know, every single app, website, or piece of software you use, it all started as just an idea, a spark of inspiration. But how do you get from that spark to a fully functioning, reliable system that people can actually use? Well, that's the critical journey we're going to break down today.
All right, so imagine this. You've got it, that killer idea, right? It's going to improve service, it's going to cut costs, maybe it'll even change the world. But the path from a great idea to a successful product, that's where most projects stumble and fall. So, what's the very next step?
You're basically standing at a fork in the road. Down one path, total chaos. We're talking disorganized work, budgets getting blown to bits, and a project that probably never sees the light of day. But the other path, that's structure. A clear, predictable road to a successful launch. The big difference maker here? It's all about having a plan.
And that plan, that roadmap, has a name. The Systems Development Lifecycle, or SDLC. Just think of it as the master blueprint for building an information system. It's this structured framework that literally guides you from concept to completion and beyond. And it's what keeps you on that path of structure and far, far away from chaos.
Okay, so who's our guide on this journey? That would be the systems analyst. They are pretty much the architect of the whole project. Their job is to translate what the business actually needs into a technical blueprint. And then they manage the entire construction process to make sure it all gets built right.
All right, so our first stop on this SDLC roadmap is the planning phase. This is where we take that brilliant idea and put it under a microscope to really figure out, is this thing actually doable? Is it worth spending the time and money on? So, to make this all a bit more concrete, let's follow a real-world example. Imagine the Mountain View College bookstore wants a new system. And look, they're not just building something new for the heck of it. There's a real business problem they're trying to solve, and that's what they have to analyze first.
Yeah, projects like this don't just pop up out of nowhere. They get kicked off because of a real business need. For the bookstore, it could be about improving service for students with online ordering, maybe supporting new digital products like ebooks, or just reducing the cost of tracking all that inventory by hand.
Now get this, before anyone even thinks about writing a single line of code, the systems analyst runs a feasibility study. This is a huge checkpoint, a real go or no-go moment. They ask 4 key questions. First, operational. Are students and staff actually going to use this thing? Second, technical. Do we even have the tech and skills to build it? Third, economic. Is it going to deliver real value? And fourth, schedule. Can we finish it before the next semester starts? If the answer to any of those is a no, the project stops right there.
Okay, so let's say our project passes the feasibility test. What's next? We move into the analysis and design phase. And this is where that systems analyst puts their architect hat back on to draw up the detailed blueprints for construction. Now, a really key concept here is something called the logical model. Before anyone even talks about programming languages or what service to use, that's the how. The team has to agree on the what. What exactly must this system do? It's a super important step to make sure they're solving the right problem from the get-go. And one of the main tools they use to figure out that what is a data flow diagram, or a DFD. It's basically a simple map that shows the journey of information. So for our bookstore, you'd see how a student's order flows from the website over to the inventory system and then finally lands with the shipping department. Simple, right?
Okay, another really important blueprint is the Entity Relationship Diagram, or ERD. This thing maps out how all the different pieces of data are connected to each other, like how a student is connected to an order and how that order is connected to a book. This diagram is absolutely essential. It becomes the blueprint for the entire database.
All right, the blueprints are signed off on. Now it's time to actually build this thing. We're entering the implementation phase. You can think of this as the construction site. This is where the programmers and developers roll up their sleeves, take all those models, and start turning them into a real working system.
Now, when it comes to the how of building, there are really 2 main schools of thought. You've got the traditional, structured method. It's predictable, kind of like building from a fixed blueprint, but man, it can be rigid. For the bookstore, that means defining every single feature up front. On the other hand, you have modern agile methods, which are all about flexibility. The bookstore might launch just the textbook search first, get student feedback, and then build the next feature. But no matter which method you choose, managing the build is always complex. There's this famous saying from computer scientist Frederick Brooks that highlights a classic trap. Just throwing more programmers at a late project actually makes it even later. It just goes to show that a good plan and a solid process are what really count. And a massive part of that process is, you guessed it, testing. You have to build quality in from the start. You can't just sprinkle it on at the end. So for the bookstore, first you have unit testing, checking if the Add to Cart button works. Then integration testing, making sure the cart talks to the checkout process. And finally, system testing, where you test the whole shebang, from login to confirmation. So, the system is built, it's tested, it's launched. Hooray! But the job is definitely not over. In a lot of ways, it's really just beginning. And that brings us to our final and maybe most important phase, support and security.
Once a system is live, its life is all about maintenance. But don't just think of this as fixing bugs. It's also about adaptive maintenance, like adding new capabilities. It's perfective maintenance for improving efficiency. And there's even preventive maintenance to head off future problems. For the bookstore, an adaptive change could be hooking into a new ebook platform a year from now.
And of course, a gigantic part of ongoing support is security. The team has to be on guard 24/7, defending the system from all sorts of threats that are constantly changing. You've got technical attacks like spoofing, but you also have clever psychological tricks like social engineering, which is basically just trying to fool an employee into giving up access to student data.
Okay, so we've walked through the entire life cycle, from that initial spark of an idea all the way to a live system. But why does all this process matter so much? I mean, why not just get a few coders in a room and tell them to start building? Well, let's wrap this up by looking at why this structured approach is so incredibly valuable.
At the end of the day, following the SDLC is what gives you that clear roadmap. It drastically cuts down your risk of failure, it helps you control your costs and stick to a schedule, and this is the big one. It makes sure that the thing you build is the thing the business actually needed in the first place.
And hey, if you need one last jaw-dropping reason why a good plan is everything, just look at this number. According to the research firm Gartner, almost 80% of a system's total cost happens after it's built, during that support phase. Think about that. A well-designed system, one that's easy to maintain and update, will save you an absolute fortune over the long haul.
This really changes how you should think about all this, right? The SDLC isn't just some technical checklist for the IT department. It is a core business strategy. It's how a company makes sure that when they invest in technology, that investment actually pays off and creates real, lasting value. And that, of course, brings us to the future. This whole structured, blueprint-style approach, it's been the gold standard for decades. But now, as we're diving headfirst into an era of cloud computing, artificial intelligence, and systems that can literally learn and change on their own, you have to wonder, how is this life cycle going to have to change to keep up? That's the huge question facing the next generation of builders and architects.